Hello, space enthusiasts, and welcome back to our channel. Remember, Oumuamua, the very first interstellar object we ever detected back in 2017. It was a cosmic mystery that had everyone talking. Its strange, elongated shape and bizarre acceleration away from the sun, without a visible tail, made some wonder if it was more than just a rock. Was it a new kind of comet, an alien probe? The debate is still raging. Well, fast forward to today, and we have a new visitor from beyond our solar system. 3I Borisov, initially designated C 2019 Q4 Borisov, discovered by amateur astronomer Gennady Borisov. This object behaved much more like we'd expect an interstellar visitor to. It had a classic, fuzzy coma and a distinct tail, just like the comets from our own cosmic backyard. So, what's the deal with these two interstellar travelers? Why was one so weird and the other so normal? Today, we're diving deep into the fascinating comparison between Oumuamua and Borisov. Let's unravel what makes them so different and what these differences tell us about the vast, mysterious universe outside our solar system. Let's start with the discovery. Oumuamua, which means scout or first distant messenger in Hawaiian, was spotted by the Pan-STARRS 1 telescope in Hawaii. It was already on its way out of our solar system when we found it, which gave us a very limited window to observe it. We caught just a fleeting glimpse of this cosmic passerby. On the other hand, Comet Borisov was detected much earlier in its journey, while it was still approaching the Sun. This gave astronomers worldwide plenty of time to point their telescopes at it and gather a treasure trove of data. The difference in observation time is crucial. It's like trying to understand a person from a single photograph versus having a long conversation with them. Now, let's talk about their appearance, which is where things get really interesting. Oumuamua was, for all intents and purposes, a point of light. We couldn't resolve its shape directly, but by analyzing how its brightness varied over time, scientists inferred it was highly elongated, perhaps 10 times longer than it was wide, tumbling end over end. Think of something shaped like a cigar or a flat pancake hurtling through space. Most bizarrely, it showed no signs of a coma or tail, which is what we expect when an icy body gets close to the sun and starts to outgas. This lack of a visible tail was a major puzzle. Comet Borisov, however, was the picture-perfect comet. From the moment it was found, it sported a fuzzy coma cloud of gas and dust, and as it got closer to the sun, it developed a beautiful, long tail. Spectroscopic analysis confirmed that its coma contained familiar molecules like cyanide and diatomic carbon, and most importantly, water. It looked and acted just like the comets we see from the Oort cloud at the edge of our own solar system. It was behaving exactly as our theories predicted an interstellar comet should. This made Borisov reassuringly familiar, while making Oumuamua seem even more strange in comparison. One of the biggest mysteries surrounding Oumuamua was its trajectory. After whipping around the sun, it started to speed up, accelerating away faster than gravity alone could explain. This is known as non-gravitational acceleration. For a typical comet, this push comes from jets of gas erupting from its surface as ice turns to vapor like tiny rocket thrusters. But remember, Oumuamua had no visible jets and no coma. This led to some wild and exciting speculation. One of the most famous hypotheses, championed by Harvard astronomer Avi Loeb, was that Oumuamua could be an extraterrestrial artifact, perhaps a solar sail pushed by the pressure of sunlight. While a thrilling idea, most scientists looked for more natural explanations. Could it have been outgassing hydrogen ice, which would be invisible to our telescopes? Or perhaps it was a nitrogen iceberg, a fragment chipped off a Pluto-like planet in another star system. This theory suggests that as the nitrogen ice vaporized, it would provide the push without creating a visible dust-filled coma. Comet Borisov, true to form, also showed non-gravitational acceleration. But in its case, the cause was obvious. Its visible coma and tail were clear evidence of outgassing. The force of these jets pushing the comet nucleus perfectly explained its slight deviation from a purely gravitational path. So, while both objects accelerated in a way gravity couldn't account for, Borisov's behavior had a textbook explanation, whereas Oumuamua's remains a profound enigma. The puzzle wasn't the acceleration itself, but the lack of a visible cause for it. So, what can we deduce about their origins from all this? Borisov's composition, rich in carbon monoxide and water, suggests it formed in a very cold region of its home star system, likely a place similar to our own Kuiper Belt or Oort cloud. It's a classic icy wanderer, kicked out of its original home by a gravitational nudge from a giant planet. It's a comforting thought, suggesting that the building blocks of comets, and perhaps life, are similar across different star systems. Oumuamua's origin is much harder to pin down. If it was a nitrogen iceberg, it might have come from the surface of a distant exopluto. If it was a bizarrely dry, rocky object, it could be the remnant of a planet that got torn apart by its star. And if it was something else entirely, well, the possibilities are still open. The fact that our very first interstellar visitor was so atypical suggests that the universe might be filled with a wider variety of objects than we ever imagined. Perhaps Oumuamua-like objects are common, but we just haven't had the technology to spot them until now. What do these two visitors ultimately tell us? They paint a picture of incredible diversity. Borisov shows us that comet formation processes similar to our own are likely happening around other stars. It's a piece of another solar system that feels familiar, a cosmic cousin. Oumuamua, on the other hand, shatters our expectations. It's the ultimate outlier, a messenger that tells us we shouldn't assume that other star systems are just carbon copies of our own. It forces us to think outside the box and consider phenomena we haven't yet conceived of. Perhaps Oumuamua represents a completely new class of object we've never seen before. Or maybe it was just a 1 in a million oddball, and most interstellar visitors are more like Borisov. The only way to know for sure is to find more of them. And thankfully, with new observatories like the Vera C. Rubin Observatory coming online soon, we're expecting to find many more of these interstellar guests in the coming years. Each new discovery will be another piece of the puzzle, helping us understand our place in the cosmic neighborhood. The contrast between Oumuamua and Borisov is a perfect example of how science works. The expected discovery, Borisov, confirms our theories and builds our confidence. The unexpected discovery, Oumuamua, challenges our assumptions and pushes the boundaries of our knowledge, sparking new ideas and new avenues of research. Both are incredibly valuable. It's a thrilling time to be studying the cosmos as we are finally beginning to sample material from other stars. These messengers are traveling for millions of years across the interstellar void to visit us, and they are bringing with them the secrets of their distant homes. So what do you think? Was Oumuamua a natural phenomenon we just don't understand yet? Or could it have been something more? Let me know your theories in the comments below. It's a cosmic detective story, and we are all part of the investigation. Thank you so much for joining me on this interstellar journey today. If you enjoyed this deep dive into the mysteries of space, don't forget to hit that like button and subscribe to the channel for more content that explores the wonders of our universe. Ring that notification bell so you won't miss our next video. Until next time, keep looking up.